In this example, we'll try to find the intervals on which the given function is increasing or decreasing. And we are going to do that by using the increasing decreasing test. So if you are not sure what is increasing or decreasing test, then please watch this suggested video. The suggested video, to click to watch that, you can click on the right top corner showing on this video. Okay. Alright, so now I hope that you know what increasing or decreasing test. So let's try to apply over here on this problem to find the interval on which the function is increasing or decreasing for this given function, which is given as a cosine form as x square over x minus 5. So let's try to do that. Alright, so if you know the increasing or decreasing test, you might have realized that to use that increasing or decreasing test, we need to find the derivative first. So let's try to find the derivative of this function with respect to x. So let's find f prime of x. So how can we find that? So since this function is in the cosine form, so what we can do is we can use the quotient rule. So how can we apply the quotient rule? So if you don't know the quotient rule, again try to watch that video that is again suggested here on the top right corner. Click on that and then watch that video. Okay, otherwise let's try to go ahead if you know the quotient rule. Okay, so how do you use it? We can first write down the function of the denominator, which is x minus 5, right, times the derivative of the top, which is here on this case x square, or derivative of the numerator function, which is x square. So what is the derivative of the x square with respect to x? 2x. So write that down, right? And then minus, we need to now write down the function of the numerator as it is, which is x square, multiply by the derivative of the denominator. So what is the derivative of the x minus 5 with respect to x? What is the derivative of x? 1. What is the derivative of the negative 5? Negative 5 is a constant, so its derivative is 0, right? So what is the derivative of then x minus 5? Just 1. So this will be everything on the numerator, right, on the quotient rule, and then everything whatever comes up divide by the square of the denominator of the given function, that means square of x minus 5. So this is the quotient rule I have applied to find the derivative. Okay, the derivative is there, but let's try to simplify if we can get on the simplified form. Okay, so how can we do that? You can see here is 2x, so we can distribute that 2x and then 5, right? So when we do that, 2x times x will be 2x square, and then 2x times negative 5 will be negative 10x, right? And then minus, and x square times 1 will be just x square. So that's what we have on the numerator, and everything under that will be again square of x minus 5. So what do we get now? Well, I mean, I can see here the like terms, which is 2x square and then negative x square. When we combine, we just get x square, right? And then minus 10x. So let's write down that as it is. So we get x square minus 10x. This is clearly a simplified form than what was earlier we had, right, on the quotient formula when we apply over here. So this is very nice. X square minus 10x divided by square of x minus 5. So this is our derivative. Why were we figuring out the derivative? Just want to recall. Well, we are trying to use the increasing or decreasing test. So to do that, we need to know what derivative mean, right? Derivative of the given function. So that's what we figured this out. Alright, so you might have noticed if you want to use the increasing or decreasing test, once you figure out the derivative, we need to see where the derivative is positive, where the derivative is negative, and then only we can apply the increasing or decreasing test. So let's now look into the other step, which is let's try to check the sign of the derivative. There are a couple of ways to do it, to check where the derivative is positive or negative, but we are going to use here the sign chart of the f prime. So let's try to draw the sign chart of f prime. Okay, so our next goal is to draw the sign chart of the f prime. So that's what we want to do it. How can we do that? So remember our goal is to check the sign of this derivative that we have obtained here, but to do that we want to draw the sign chart of the f prime. So let's do it. So what can we do here? So to create the sign chart of the f prime, what we first need to know is, okay, first just draw a real line, okay, so which is maybe a line extending towards, let's say, negative infinity to positive infinity. Okay, first do that. Very easy, right? Now after that, let's try to see what are the partition number of the function. The partition number of the function here we can use is where the function is undefined. So if you look into the function, or just find the domain of the function. On this case, what is the domain of the function? So if it is a cosine function like x square over x minus 5, you can see that the denominator will be 0 when x equal to 5. So if the denominator is 0 at 5, then the function is undefined there, right? So if that is the case, let's use that to partition the given real line right over here. Okay, so let's try to see here, somewhere over here I wanna use 5 over here to partition this given whatever we have real line we have drawn earlier. Okay, so this is good. So we have here one number which partition this negative infinity to positive infinity. Now we already have two sub intervals from negative infinity to 5, 5 to infinity. Well, but we are not done yet. We also need to see what are the partition number of the f prime to determine some sub intervals where maybe the sign changes. Okay, so to do that, let's try to see what are the partition number of f prime. How do we get that? Okay, first we need to see where f prime is undefined or f prime does not exist. So you can see here on this example we have already obtained this f prime, which is x square minus 10x divided by square of the x minus 5. This is again a cosine form, and where this function does not exist, again where the denominator is 0, that means again when x minus 5 is 0, then again from that we just see that f prime is also does not exist at 5, but that number is already here, so we don't need to repeat that again. Okay, that's nice, but there are still some more partition number that might be useful here. The another number is where the derivative is 0. So let's try to see the computed derivative that we have figured out earlier, where that will be equal to 0. Okay, so we have x square minus 10x divided by square of x minus 5. Let's set that equal to 0. And what do we get here? So we're gonna just solve for x, but on this case we get the rational equation, right? So how do you solve the rational equation? We need to multiply by the lowest common denominator on the both side. So on this case we have square of the x minus 5. Let's use that to divide on the both side. Then we get x square minus 10x on the left hand side is equal to 0 times square of the x minus 5. So we just get 0. This is very nice. We have the rational equation. Now we convert that into the polynomial equation, and on this case it is just the quadratic equation. We know how to solve that, right? How do you do that? Well, use the one way you can use the quadratic formula. Other way, try to see if you can just reduce up to the linear factor. So let's try to see that. So I think it's very easy to factor, right? We can take the x out as a common factor. When we do that, I have x times x minus 10 are the factor. Set that equal to 0. When you do that, we can clearly see by using the 0 property, either x will be equal to 0 or x minus 10 equal to 0. So these are the only two possibilities, right, to have the x times x minus 10 equal to 0. So on the if that is the case, we already have one of these possible solution, right? So either x can be equal to 0 or x minus 10 equal to 0. So if that is the case, if you solve here the second linear equation, we get x equal to 10. So you can double check either at x equal to 0 and x equal to 10 this derivative is 0 or not, but I think that it will be. We can double check that. But now what I have here is two numbers, one of them is 0. Let's use that to partition the domain of the function, right? And then another one is 10. So this is how we get this partition number, which will help you to get some sub intervals where maybe the sign will change, sign of the f prime. So this is how we construct the sign chart. Okay, so first we need to have this partition number. Okay, until now I don't know what is the sign of f prime, right? So let's try to do that. Okay, so now to determine the sign of the f prime on each of these subintervals. Now we can just choose some random number within each of these subintervals. So let's try to determine by yourself whatever random number you want to choose. I want to choose here, let's say -1. Let me make it a little bit thicker sign. Okay, so let me write down here -1. So because -1 lies between -infinity to 0, I want to choose that. If you like some other, you can choose that. Between 0 to 5, I want to choose 1. And over here between 5 to 10, maybe 6. And then from 10 to infinity, you can choose million, billion. I'll just choose here not 10, by the way, 11, let's say. Okay, let me choose that. All right, so let's choose these random number, and what you just need to do is plug all of these random number that we have just chosen into the derivative, and then see what is the number you get, especially what is the sign of those number, either they are positive number or the negative number. Just try to get that. For example, if you plug back -1 in over here on the derivative, what do we get? Square of the -1 minus 10 times -1 divided by square of the -1 minus 5. On the denominator, since we have a square of something, so no matter either you choose whatever number result we get over here, the square will be always positive. So denominator is always positive. In the numerator, on this case, you can see square of the -1 is +1, and -10 times -1 will be -10 times -1 will be +10, and then square of the -1 is 1. So altogether, what do we get? I don't care even what number you get, but can you tell me the sign? It will be actually positive, right? So it is actually greater than 0, or you can say it is positive. So if that is the case, let's write down here the positive sign. In the similar way, plug 1 in to the derivative. Okay, so if you find the derivative at 1, and then see the sign of the number that you get from here, and then double check if that is negative or not. Similarly, 6, plug back in on the derivative again, check what you get over there. Okay, similarly, plug 11 in on the derivative, and then see what type of number you get, positive number or a negative number. All right, so please do that. So this is how we create the sign chart. Good. Why are we recreating the sign chart? Well, we want to know whether the derivative is positive or negative. Do we know that? Yes. All right. But why were we looking into looking into the sign of the derivative? We wanted to use the increasing decreasing test. Okay, but what is increasing and decreasing test? Now how that can conclude to actually solve our main problem, which is find the intervals on which the function is increasing or decreasing. Okay, I hope you have figured out, some of you. If not, let's try to see. What the increasing and decreasing test says is, if the derivative is positive on certain interval, let's say from, you can see here between -infinity to 0, right over here, we see that the sign of the f prime is actually positive. So what the increasing decreasing test says, if the f prime is positive on some interval, function must be increasing. So let me represent this by a notation to maybe recall later on that function was increasing there because of the increasing decreasing test. In the same way, you can see between 0 to 5 on this interval, since f prime is negative, right, the function is decreasing. By what? By the increasing decreasing test. In the same way, from 5 to 10, the function is again decreasing, and from 10 to infinity, the function is increasing. So this is how we can summarize the fact, and which we'll write down here as the function f is, this is our conclusion, okay, by using the increasing decreasing test. F is increasing on, where was it increasing? From -infinity to 0, right? And then from 10 to infinity. Within these two sub intervals, the function was increasing, which we can combine by this union sign, and this is how we write down. Okay, in a similar way, we can say that f is decreasing on what were the intervals we figure out, from 0 to 5, right? Okay, let's write that down. And what is the another interval? From 5 to 10. So between these two sub interval, the function is decreasing because the sign of the derivative was, right, the f prime was negative, and by using the increasing and decreasing test, we can conclude. Oh, by the way, I forgot to combine these by the union sign, not the intersection. Okay, that would be a different meaning, right? Okay, all right, so that's it. So we are done.